We want to write from logarithmic to exponential. What's the catch here? M in front. Anything else? And the 5. The 5 is only attached to the log if it was like n plus 5 in brackets. Is it n plus 5 in brackets? No. We can only change to exponential if and only if we have log with a 1 in front, correct? And then the log equals something. That's what it has to be. Log equals something in order to convert. So we have to move the 5 first. So we're going to get m log t n equals q minus 5. And then we divide by m. And we get log p n equals q minus 5 over m. What can we do? You can. Yep. You want to move it to the exponent first? In the end, you would just end up dividing it by it anyways. Like you do the same thing you're going to do. I'll show you. Do it your way, since that seems to be the way everyone did it. Log p n m equals q minus 5. Then we convert, right? P to the q minus 5 equals nm. N to the exponent m. Is that there? Okay, sometimes it's not. What could we do? Sometimes it's in n equals. And honestly, that happens more so than not. So you get this answer. This answer's nice. It's there. This is true. This is good. But they won't have it in just n. So they go one more step. How do I get rid of the m? If it was a 2, everyone would say square root 2. Like square root it, right? If it was cubed, everyone would say we cube root it. If it's an m, you could m root it. But what the heck is that? That's why I told you guys to remember, if you want to get rid of an exponent, you multiply by its reciprocal. So this would be 1 over m. And then you'd have p to the q minus 5 over m equals n, which is what I was going to get as an answer. But if had this been my answer, which is what my answer would have been, right? Then I wanted to have it as n. I would just raise this to the 1, sorry, I would multiply this to the m, right? And then I get it over again. But that could be another option. It's not there. They didn't make you go further, but sometimes they do. That's that extra step that tricks people, right? You get the answer and you're like, yeah, I got the answer. And then you're like, no, it's not there. It's so close, but it's not there. Okay. This one's tricky as well. First off, the 9s are out. If you have the same base, you guys, you do not multiply bases. It's like x2 times x to the 2 is x to the 4, right? These have the same base 3 and base 3. So when you have 2 bases and you're multiplying, what do you just do?
Leave it.
No, what do you just do? What do you do with the exponents? Yeah, you add the exponents. So if you have 2 bases that are the same, you write the same base over and you add the exponents. So you're going to get 2 log x's, right? Good answer, but it's not there. So you can bring it up as the exponent. So you can go 3 log x squared. Now is it 3 log x squared, or is it 3 log x squared like that? Like that. The 3 log x squared is there to mess you up if you forget, if you think you need to multiply these instead of adding them. Because what's log x times log x? Log x squared. So that's where this answer is coming in. It's wrong if people forget to multiply or think they need to multiply. It's also wrong because some people just think, oh crap, now is this or this the rep? Do I put the whole thing to the 2 or it's just the x to the 2? It's just the x that's to the 2. So it's A. For 3, the catch is that 2 in the bottom. Everyone's usually pretty good about the rest. Some people are just right out to lunch. They'll like keep the 2s and 3s and they get this crazy answer. It's not even there, so they just pick something random. But remember that if you're doing adding and subtracting. Remember that if you have common base, you can put them together. Most people don't spot this as common base because it doesn't have the physical 10. Okay, if I put a 6 down there or a 5 down there, most people would put these together way faster because they would spot, hey, they all have the same base. But the moment it's just base 10 and the 10 is gone, people don't spot that they're all the same for some reason. Okay? Now, I've told you before, when you have a fraction, that's just the same as having a coefficient. So, this is like 2 log x minus a half log z plus 3 log y. Most people, if they can spot that that 2 on the bottom is just a half coefficient, the rest is really easy. In order to do these and put them together, we have to have a 1, positive 1, or a negative 1 in front. So I'm going to bring the exponent up, or the coefficient up as the exponent. So log x squared minus log z to the half plus log y cubed. Now I can put them together because they all have a 1 in front, a positive or a negative 1. So I go log. Anything with a positive 1 in front stays on the top. Anything with in the numerator. Anything with a negative 1 in front goes to the bottom, to the denominator. Okay? So x squared stays on the top. Y cubed stays on the top. Z to the half goes to the bottom. What is anything to the power of a half? Square root. So which one is it? Number 4, questions like this are given often. They'll give you some information and another piece of information, and then they ask you to find the value of something that doesn't have an equal sign. So, the value of log base 3, 9ab squared, I see that and I instantly think expand it. And I think to expand it because I know log base 3 of 9 is 2. It's a nice thing. So I expand it out. You have to remember that everyone's really good at remembering to put plus and minus signs together as multiplication and division. Everyone's really terrible at remembering, hey, I can expand them. Okay? You have to remember that. So I can rewrite this as log base 3 of 9 plus log base 3 of a plus log base 3 of b squared. Now we have log base 3 of a equals 6. So this is actually equal to 6. Plus log base 3 of 9 is 2. This one's our issue. I don't have log base 3b. I have log base 3 of b squared. How can I make that be log base 3 of b? Take the 2 and do what with it? Move it to the front. You don't want to leave it as the exponent because then people do 5 squared. It's not 5 squared. Okay? That answer will be there also if it's a multiple choice. They'll assume you're going to do 5 squared. You have to move that 2 to the front. When you move the 2 to the front, then you have 2 times log base 3b. So you're going to have 2 plus 6 plus 2 times 5, which is 2 plus 6 plus 10, which is 18. If I fill in my numeric response boxes, left to right, 1 and 8. If you do not round correctly, if you do not put them in the boxes correctly for this test, you're losing 0.5. The next test after that, you're losing everything. Because on your diploma, you would lose it all. You wouldn't get part marks. They wouldn't be like, oh, Muffin, you were close. No, wouldn't work. Okay? These ones we'll do in a... Students work to simplify a logarithmic expression as shown below where a is greater than 1. A has to be greater than 1 anyways. 2 log a x to the 4 minus 3 log a x squared plus 4 log a x cubed. You take those numbers, you bring them up, and they become the exponent, right? When you bring this 2 up and it becomes the exponent, when you have an exponent times or an exponent beside an exponent, you multiply them, right? 1 base, 2 exponents, multiply. 2 of the same base, 2 exponents, you add. So 2 times 4, 8, good. 3 times 2, 6, good. 4 times 3, 12, good. Those are all good. Anything with a plus 1 in front goes to the top. Anything with a minus 1 in front goes to the bottom. So this goes to the top. This goes to the bottom. This goes to the bad. Step 3. Now, where he first recorded his error, people, if you're like, but it's in his brain in between 2 and 3 messed this up. So is it 2 or 3? It's where he first recorded his order. I can't even speak. So he first recorded his error. When's the moment he wrote down his error? Here, this is an error. This is not an error. It's 3. Okay? The equation of the asymptote of the graph of y equals log b x minus 3 plus 2, where b is greater than 1. People are like, I can't put in my calculator. It has a b. It tells you b is greater than 1. You could put in a 2. You could put in a 3. You could put in a 4. You could put in a 5. And then you could look at it. Right? It's not going to change your asymptote. So whenever they give you this thing, b is greater than 1, or a is greater than 2, you can put stuff in for them, you guys. It's not, you're not stuck, right? Put in a couple and see if it changes the asymptote. It's not going to. You're going to spot that. Now, we don't actually have to do that. You don't have to put in your calculator, but that's a last-ditch effort. But the asymptote of a log is always, if it hasn't been transformed, at x equals 0, because it's a vertical asymptote. So what's going to move that? It's a vertical line. The only thing that's going to move it is shifting it to the right or the left, correct? So just this, which just means I'm moving 3 to the, so it's actually now going to be at, the only thing that moves vertical, or the only thing that moves exponentials are vertical. Students sketch the graphs of f of x equals log base a of x plus 3 minus 7 and g of x equals a x minus 2 plus 5 where a is greater than 1. Once again, you could put in 2 for the a's, right? She drew the asymptotes of the two graphs using dotted lines, the intersection. Okay, so a log graph has a vertical asymptote at x equals 0 unless it's moved horizontally. It's moved 3 to the left. So now it's at x equals negative 3. This one has a horizontal asymptote at y equals 0 unless I'm moved vertically. I moved vertically 5 up. So it was at 0. It's now at 5. Just like that. Oops. Okay, what do we have to remember for this one? Take the 3 out. Y equals log b 3x plus 4. So my asymptote is normally at x equals 0. It's now been moved 4 to the left. So it's at x equals 4. Yo. So the catch here, though, and in this one, it's actually a way nicer question. They wrote it way nicer. But it's going to be this one because it's greater. What would make it to be less?
Well, the non-log exponential.
No, what would make it to be less?
Oh, lower than
A reflection in what?
Oh.
Y-axis. Because the log is normally going like this. If I reflect it in the y, it's going to be over here, and it's going to be less than negative 4. Okay? So if you actually, if this was a negative 3 in front, you can write this if you want. If this changed and it was negative, where did I put the log? Good one. Equals log b. Say it was negative 3x minus 12. I would still have log b negative 3x plus 4. So it would still be 4 to the left. But this little negative sign in front would cause it to reflect in the y, which would make it actually be what? X is less than negative.
Could it also be x less than if there's a value that's less than 1?
No.
What would happen there?
You can't have a b value less than 1. That b can't be negative or 0.
I thought you said if it's between 0 and 1, it's going to be
Exponential.
Oh, that's weird.
And it would be between 0 and 1. It would still do the same thing, but you have to think about it. It's 0 and 1, not negative. 0 and 1's a fraction. Right? Like a half or a quarter or a third. Or can't be negative, can't be 0, can't be 1. Okay. This one, the y-intercept, the moment you hear y-intercept on, oh, that's underlining, by the way. The moment you hear y-intercept on the test, you should always think x equals 0. You should dream about it. It's that important. Okay, so f of 0 is what we're finding. A 0 plus 1 plus b. So it's going to be a to the 1 plus b, or a plus b. That easy. Now 10, if you forget about common base, for number 10, you're going to log both sides, you're going to take it, you're going to drop it in front, you're going to have to distribute, you have to collect the x on one side, everything else on the other, you have to get it together and all that jazz. Or you can be like, hey, whenever I'm solving exponential, the very first thing Mrs. Lepp told me is to check for common base. Not always is there a common base, often there's not. But what if there is in this case? It'd be way faster. I can make them both be base 2. So 8 is 2 cubed, 3x plus 4. 4 is 2 squared, 3x minus 9. So you're going to get 2 to the 9x plus 12. You remember to distribute it. Equals 2 to the 2x minus 18. Same base, you can set them equal. 9x plus 12 equals 2x minus 18. Subtract 2x. 7x plus 12 equals negative 18. 7x equals negative 30. X equals negative 30 over 7. I'll give you about 10 minutes, and then we're going to go through the next 6, because I want to get all 28 done by the end of the class. Earthquake intensity is given by I equals IO times 10 to the M, where IO is the reference intensity and M is the magnitude. An earthquake measuring 5.3 on the Richter scale is 125 times more intense than a second earthquake. The Richter scale measures of the second earthquake to the nearest tenth is. This is an actual diploma question. I'm not even sure where you'd put all the stuff to get it. Thanks for the formula. I just say boo to your formula, and I use my formula. I'm not even sure where you yeah. So, I can't even tell you where they're going with it. That's my problem. Like, so I did 10 to the M1 minus M2. Intensity is 125. Because the intensity is really large, M1 is the large earthquake, right? If the intensity was between 0 and 1, M1 would be the small earthquake. They don't always give you M1. They sometimes give you M2. An earthquake is measuring 5.3 on the Richter scale. An earthquake measuring 5.3 on the Richter scale is 125 times more intense than the second earthquake. Is it the larger one? Yes. Do they always give you the M1? No, please don't assume that, okay? Don't assume that. So 10 to the 5.3 minus M2. Now, there's 2 ways we could do this. One, we could do Y1, Y2. You'd have to make sure your Y max was at least 125 or you're not seeing it on your calculator. 2, you can convert it to a log. These ones are nice to convert to logs because the base is 10. Okay, so I'm going to solve it that way just to prove it. So it'd be log base 10 of 125 equals, my computer's lagging, 5.3 minus M2. Then I'm going to move my M2 over here and subtract that. So I'm going to go M2 equals 5.3 minus log 125. Oh my gosh, computer. So, why can't I just drop the 10 off? Log is always to the base 10. So 5.3 minus log of 125, I should get an answer lower than 5.3 to the nearest tenth. What'd you get? You just round them normally. If it's below 5, round down. If it's above, round up. The population of a particular town on January 1st, 2008 was 15,000. The population of the town on January 1st, 2016 was 32,450. What's the annual rate of increase? So, initial, 15,000. Final, 32450. It doesn't say compounding in it, so it's not a compound interest question with the CP. It doesn't say a half-life doubling, tripling time, so it's not one of those. So it's just the 1 plus or the 1 minus, right? In this case, it's annual rate of increase, so it's going to be 1 plus I. How many years? 8. Divide by 15,000. The T over P? What's the T and the P?
And then how long it takes to half double.
Yeah, but how long does it take to half and double and whatnot?
A year. Annual rate.
No, the annual rate just means what the interest per year, which is just I. So you're going to go 32450. It doesn't half every year. This is 8 years, and it's just under half.
But it's like average annual. So it could be like the average for each year. No, okay.
So you're going to get 649 over 300. You cannot round until the very last answer. Equals 1 plus I to the 8. You could put this in your calculator, but I'm going to solve it mathematically. 7 raised to the 1/8. And then I'm going to get a decimal. And then what am I going to do? Subtract 1. So you subtract 1 from both sides. And you get 0.10126 blah, 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 which is what? 10%. If it doesn't say doubling, tripling, or half, or anything like that, you can't use that one.
Yeah. But I just went rogue on that, and I kind of just typed in.
Don't go rogue.
1.1.
Don't go rogue.
Like every year, it's 16,000 times 1.1. You get almost together.
But times by 1.1 is 10%.
Yeah, and
That is the
I
answer.
didn't get what it was. Like I thought it was saying, like what would it?
If you're multiplying by 1.1, you're multiplying by 110%, which would be correct. So the answer would have been 10.
What?
If you were multiplying by 1.1 and got the answer, which is what you did, that wasn't incorrect.
110% each year, but
yes, but that's 10% extra each year because
yeah,
100 is original. So you would have actually been right. You just picked the wrong answer. Yeah. Jordan needs 6,000 to take on his trip. It says compounded in here, so I'm instantly going to use that. Oh, come on. Okay, Jordan needs 6,000, so that's his final amount to take his family on a trip. He's able to invest, to make an investment which offers an interest rate of 8%. So that's 1 plus 0.08 divided by compounded semi-annually 2. How much should Jordan invest now to the nearest dollar so he has enough to go on a family trip in 3 years? 3 times 2. So you're going to go 6,000 equals x times 1.04 to the 6. And how do we get x by itself? Divide by 1.04 to the 6. Because you have to. Compound semi-annually. Divide by CP and times by CP. You divide the interest by CP and you times the years by CP. Yeah. So it's 7,592. 7,500, that doesn't even make sense. Come on, guys. How does that even make sense? You're all just writing it. Like, that means he invested money and lost money. Here, I used multiplication instead of division. Yeah, that's, you need to get a new bank person. Divided by, I used a multiplication. 4,042. 4,742. 14, an expression that is equivalent to log 2 sine x sine 2x. Okay, so 2 sine x sine 2x. We're going to have to somehow replace. Sine 2x is the only one you can replace right off the bat. It's 2 sine x cos x. So we're going to get 2 sine x up here, and then sine 2x off the formula sheet is 2 sine x cos x. The 2's cancel, the sines cancel, and you're left with log 1 over cos x. So people get to there, usually they're really good. Whenever we have a fraction, 1 over 4, we could write that as 4 to the, so if we have 1 over cos, we could write that as, and then we can bring that in front. Speed up, man. No, it's 1.04 to the 6. 1.04 to the 6.
Oh, I see. This is a good cumulative question.
Mm-hmm. On the diploma, they put units together.
That sucks.
Yeah.
Screw them.
Hey, they're wonderful people.
They suck.
They're great. No, they're awesome. You stop with your madness and your
I
negativity.
should write up a letter. You guys stop.
Yeah, that would be super, yeah, super helpful.
After I write my diploma.
Super helpful. No, that would be stupid. I mean, not very smart. Flauner. Okay.
All right. Hey, I got this all by myself.
The catch on this one is you guys haven't done this one before. I just wanted to bring it up here so you could see. It's just like the magnitude questions. It's just like the earthquake questions. The catch is, though, that the formula uses bells, not decibels. Okay? So you're going to get your question in decibels. Stop talking. You're going to fill in bells, and then you're going to convert back to decibels. It's really easy. It's just one decimal place. Okay? It's not going to be a huge deal. So 127 decibels is 12.7 bells. That's it. Like, it's not hard to convert. But the formula only uses bells. It doesn't use decibels. Okay? Great. They gave us that formula. Don't really care. I'm going to use the formula I like. I equals 10 to the m1 minus m2. Okay. The loudness of sound is related to the logarithm of the ratio of the measured intensity I to the reference intensity IO. The loudness L of a sound is measured in decibels, dB, and can be determined using the formula blah. Determined during an international soccer tournament in 2010, a noisemaker called the Vuvuzela had a measured loudness of 127 decibels, or 12.7 bells, at full volume. If the intensity of the sound of the Vuvuzela is 5,000 times greater than the intensity of the sound of a lawnmower, wow, that is an intense, wow, that is loud. Wow. Then the measured loudness of the lawnmower to the nearest decibel is, okay, intensity, 5,000. So it's a big intensity. So my M1 is going to be big. Is the 12.7 bells the bigger intensity or the smaller? Is the Vuvuzela louder than the lawnmower? Yes. So it's the bigger one. So 12.7 minus M2. Solve it like you did. So you can go Y1, Y2. If you do that, your Y max has to be at least 5,000. Okay? So you're going to get, if not, you're going to solve it. Log base 10 of 5,000 equals 12.7 minus M2. I'm going to move the M2 over here, and I'm going to move the log 5,000 over. So, put in 12.7 minus log 5,000. And you get 9 bells, which is 9D decibels. This formula that I use only uses bells. Like, you can only put bells into it because it's base 10. If you wanted to use decibels, you'd have to make it be base 100. And then you have to remember a different formula. So I just like using the same formula and converting to bells. Yeah.
If it says 158 times less, that means like 1.58. 158 times less.
Intense? No, you would use 158 still, but it says what is the magnitude of an earthquake that is 158 times less is intense. So they're looking for the smaller earthquake.
Oh, so okay.
So once again, you're giving them one.